All right. So today we have a lot more people than we normally do. That's awesome. We are continuing our kind of refresh from last week. So yesterday I talked about earthquakes and gave you time to finish the earthquake assignment from when I was gone. Today we're going to do the same thing with volcanoes. So I'm going to talk about some cool volcano stuff. That way you actually have this information in your notes. So talk about actual volcano stuff. I believe Volcano Day was an Edpuzzle. So if you are having trouble figuring out how to log on to Edpuzzle, if you don't have the class code, check that assignment out. And then if you still can't get in, please let me know. Because I think if we ever have to try virtual stuff again, Edpuzzle will probably be something we do a lot more often. So here's hoping we won't have to, but just in case. So I want to make sure everybody knows how to use it. Tomorrow we start new content again. We are going to talk about thunderstorms, which is our last like natural disaster weather kind of thing. Thursday we're going to review all of the natural disaster kind of stuff. Make sure that you have everything for that natural disaster safety sheet. And then Friday we'll do some sort of activity with all of that information. So before I get into anything else, does anybody have any questions, comments, concerns, fun anecdotes, knock jokes? No? All right. So volcanoes. We are going to explain how volcanoes form, why they erupt, and the safety precautions that need to be in place both during, before, and after a volcanic eruption. This isn't working. Let's click this. Where's my cursor? There it is. All right. So, what is a volcano? A volcano is a rupture in the crust of the earth that allows hot lava, volcanic ash, and gases to escape from a magma chamber below the surface. So, you've probably seen some sort of volcano imagery before. Underneath this volcano, like miles down in the ground, there is let's see if I can actually write on this. Nope. There is a giant magma chamber underneath this volcano. So if this is the Earth, this is our volcano. Oh. Underneath is a giant chamber of magma, which is molten rock, and a volcano is where that magma can come out of the earth. Just weak points in the earth's crust that allow this hot melted rock to come out of the earth. Now the pressure builds up because of how hot magma is. Also, as water seeps through the earth's crust, it can turn into steam. Steam can help build up that pressure as well. So, a volcano is a rupture in the earth that allows hot lava, volcanic ash, and gases to escape from below the earth's surface. We'll talk about the difference between magma and lava, but I believe first we've got the different types of volcanoes. So, let me know if I get going too fast. My brain's not on 100. It still isn't even clicking, so. Oh, I drew the magma chamber on this computer over here. There we go. All right, try this again. So, how do they form? When a volcano forms, hot molten rock, ash, and gases escape from the Earth's crust, and that molten rock and ash solidifies as they cool. So we've got our molten magma, which is our melted rock way below the Earth's crust, and it forms a vent, just kind of a crack in the Earth's surface. And that magma can rise up, and that it will become lava, and that lava will solidify outside of that vent. It kind of builds up and builds up and builds up, like you would, like if I had like a Ziploc baggie full of icing, I just kind of squeeze it from the bottom. Eventually, that icing would build up and build up and build up if it had something to stand on, which it does, the Earth's crust. I probably should have had a physical thing. But so as more and more molten rock comes out of that fissure in the Earth, comes out of that vent, it will build up and build up and build up and create a mountain. Or if this vent is on the surface of the ocean, like the ocean floor, it'll form islands. This is how Hawaii happened. So we had these underwater mountains. So underneath the Earth, there was a fissure in the Earth's crust at the bottom of the ocean. And as the magma came up out of that fissure, it built up and it built up and it built up until eventually it breached the ocean's surface. So now we have a chain of islands. We have a chain because as the Earth's crust moves, as those tectonic plates move over millions and millions of years, where that fissure is will stay in place and the crust will move above it, which is why you can kind of trace how those tectonic plates have moved by where the islands are, which is actually super cool. Is why Hawaii has a lot of volcanic activity, because it was created by volcanoes. Super cool. Yeah, does anybody have any questions about this? No? Okay, so there are different types of volcanoes. Lots of different types of volcanoes. The first one is a fissure volcano. These are our gentle slopes, kind of like our deep sea vents. So the ones that just kind of spread out and spread out and spread out and aren't like big tall mountains. We have our shield volcanoes, which has a more gentle slope. We have our cinder volcanoes, which was made by sediments of ash. So instead of having rock buildup and rock buildup, it is solidified ash, so the dirt is a lot more fine. The difference between a cinder volcano and a stratovolcano, which are kind of the most common, is these pipes that comes out through. So the vent that came up kind of branched off, and those are stratovolcanoes. We have dome volcanoes. These are volcanoes that happen relatively quickly, so they aren't as like nice and pointed. They will dome in on themselves because the lava came out so fast that the top of it didn't necessarily get formed as strongly as the other ones. And then we have our caldera volcanoes. Our caldera volcanoes often happen after one of these stratovolcanoes explode, just like below the top off of it. If you cut it like a plateau, this is what happens. And you can see how we have old cones and new cones because our pipes in our stratovolcano are still coming up in different portions. Now, these don't often have like open exposed magma lava. There's usually like a earth crust like top to it, so these things still can build up pressure and explode. So cool here. All right. Next, where do volcanoes form? All you need here is that they are often found where tectonic plates are diverging or converging. So just this first sentence right here, you'll get the Ring of Fire stuff in that Ed puzzle. So we've got our tectonic plates, like we learned about yesterday. Um, our tectonic plates that we learned about. I can get my words out today. Most of our volcanoes happen right here along our ring of fire. Now, volcanoes can happen anywhere. They can happen smack dab in the middle of a plate. In fact, Yellowstone is over here. That's a super volcano that has not erupted. It's not on a plate, but it still exists. Let's see. Where is it? Yeah. Okay. So most of them happen right here. I talked about the Mid-Atlantic Ridge. So this bit right here in the middle of the Atlantic Ocean, that is where we get a lot of volcanoes as well, especially those deep sea ridges that spread apart from one another. Does anybody have questions about the Ring of Fire? Why it's so important? Most of our Earth's volcanoes are actually underwater. We don't see a lot of them. I mean, most of our planet is covered in water anyway, so it makes sense statistically that most of them are underwater, which is good for cooling processes because if a volcano explodes underwater, it's not necessarily going to be as disastrous as if a earthen volcano were to erupt. And we'll talk about some more like really cool volcano eruptions from the past as well. So the Ring of Fire is where roughly 90% of all earthquakes happen. So this Ring of Fire right here, as you can see, we hit the San Andreas Fault. We get the entire coast of Chile. 90% of our earthquakes happen in this Ring of Fire. It just has to do with this specific plate being where it is. We also get Japan as well. They're all on this plate, and about 75% of all active volcanoes on Earth happen in here as well. So South America has a lot of earthquakes and volcanoes, as well as some volcanic eruptions over here. There are a couple active volcanoes in California as well. But yeah, no. So volcanoes aren't necessarily isolated to this. In fact, we've got all of the volcanoes in Iceland over here that aren't classified as part of this 75%. But we have Hawaii, which is somewhere in there as well. It's all volcanic eruptions that happen in that ring of fire. And that's why they call it the Ring of Fire, just because we get most of our volcanoes, most of our earthquakes within there. Yeah. Any questions? So the difference between magma and lava, a lot of people get them mixed up. Even a lot of like text sources online get them mixed up. The only difference between magma and lava is location. Just like the only difference between a hurricane and a cyclone is where they happen on Earth, the difference between magma and lava is where it is. Magma is found inside of the Earth, and lava is found outside of the Earth. They're both just melted rock. So this big tunnel of melted rock right here, that is all magma. But as the magma erupts out of the volcano, it becomes lava. So if it's exposed to air, if you are seeing it with your eyes, it is lava. But if you are detecting it with like equipment that measures density of the Earth, it would be magma. So magma is found inside the Earth, lava is found outside of the Earth. They're both made of the same exact stuff. Just the instant that magma touches the air, it is considered lava. Why we did that, I don't know. I think scientists just like to name things. So, there's that. Volcanic eruptions. So the explosivity of the eruption depends on what the magma is made of. So if the magma is thin and runny, so if that magma, just the rock that melted, So different rocks melt at different temperatures and have different consistencies. The runnier it is, we don't necessarily have our eruptions. They can just flow easily out of the fissure, and we get these fun, slow little lava flows. If you ever see some like a human interacting with lava, odds are it is a lava flow. If you've ever seen those videos of people like tossing pop cans into lava to see what happens, I'll try to find one. But that is considered a lava flow. This is what happens in Hawaii a lot of the times. You'll see a lot of Hawaiian lava flows. So if it's thin and runny, gases can escape from it very easily, which means gas doesn't build up, pressure doesn't build up. We don't get the big. But if that magma is thick and sticky, the gases can't escape easily, and the pressure builds and builds and builds and builds. So just like with earthquakes, as our tectonic plates, that friction builds and builds until it finally gives way. Our volcanoes have a similar thing with friction. As the lava is super, or magma, I guess, super, super thick, gases can't escape from it. And as those gases build up and build up and build up, eventually explosion. So, damage. So lava flows, while you can probably easily outrun them, and these pyroclastic flows, direct contact with this stuff is devastating. A volcanic eruption can involve lava, debris, ash, these little volcanic rocks called pumice, that can flow up to 100 miles an hour, destroying everything in their path. In fact, these pyroclastic flows, which is solid lava, volcanic ash, and gases, as that ash explodes out of the top of a mountain, it creates these pyroclastic flows. And those are very, very hot, can move up to 200 miles an hour, and will destroy everything in their path. So I've got two pyroclastic flows pictured up here. Essentially, the tops of these volcanoes just blew, and as that gas buildup had created the pressure, created all of this ash, which is completely it'll just wreck everything. But there are a lot more damaging effects than this. In fact, most of the damage from volcanoes isn't because of pyroclastic flows, it's because of the ash that is left in the air after the fact. In fact, we think that one of the ice ages, I'm not sure which one, but an ice age, like millions and billions of years ago, we had a super volcano, like the biggest volcanic eruption in Earth's history, put so much ash into the atmosphere that the planet essentially went dark. The planet goes dark, the sun can't penetrate that layer of ash in the atmosphere. Ice age. So volcanoes, while the ones that happen in our lifetime aren't necessarily as dramatic as that, people think that in thousands and thousands and thousands of years, if the volcano under Yellowstone National Park ever blew, we would go ice age again. So the odds are isn't going to happen in our lifetimes or any of the lifetimes after us, but is like a fun little like scientific tidbit to throw around. So other hazards that happen with volcanoes that aren't necessarily pyroclastic flows or lava. Contaminated water supplies. There is a lot of sulfur in volcanoes. There's a lot of carbon dioxide built up in volcanoes. That stuff can leach into water. That volcanic ash can leach into water supplies, which is not good for us to digest. Damaging machinery. So that ash that comes out of volcanoes is microscopic. It is so tiny, it can get into finely working machinery and just destroy all of it. Reduce visibility through smog and harmful gases. So a lot of times volcanoes will, or people who live in volcanic areas, will just have straight up evacuation notices because humans cannot breathe in that ash. A lot of deaths that have to do with volcanoes have to do with the inhalation of that ash, or people just suffocate because their lungs fill up with it. And then, makes it hard to breathe, irritates the eyes, skin, nose, throat. That ash can get in every little crevice. So that's our biggest danger when it comes to volcanoes, is that ash that people breathe in. We'll talk about the city of Pompeii later, where most of the deaths there didn't necessarily happen from being buried, but happened from suffocation before they could be buried. So yeah, those are our volcanic hazards. Safety. So safety is a big thing on your natural disaster safety sheet. You don't have to have this word for word, but I chuck a couple things on there. So number one, listen for emergency alerts. Being aware of the National Weather Service or the CDC or whatever volcanic service happens. Being aware of what is going on is the first step in any natural disaster preparation. Follow all evacuation procedures. If you live in an area with volcanic activity and somebody tells you to evacuate, you evacuate. The survival rate for being in those areas is not the greatest, especially if you've got major evacuation rates. Protect yourself from heavy ash fall and do not drive. So, driving is a relatively common thing, especially if you are trying to get out of it. But the second you cannot see, it is no longer safe. If you must drive, down here, if you must drive, keep all your windows up. Do not use the air conditioning, even if it is hot. If you use the air conditioning, it will take in air from the outside, therefore taking in ash from the outside, which you do not want to breathe in. Let's see. Cover ventilation openings and seal windows and doors. So if you do not evacuate or you do not have warning and you are in your house, whenever a volcano erupts, you stay in your house until emergency services can get to you. In order to survive, you seal all ventilation, seal all windows, seal all doors. So not letting the ash that is in the air outside get to your house on the inside. If you have to go outside, use a respirator. Our COVID safe masks are not ash safe masks. That is where our respirators come in handy, because that ash is super microscopic. Even the air that you take in or in the crevices from the outside is not safe for you to breathe. Let's see, one more. So, also, if a volcano erupts, you have to be wary of your roof. That ash that comes out of volcanoes is tiny, 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 tiny bits of rock. So, if a ceiling or a roof gets covered, if a roof gets covered in that ash, and then it rains and that ash gets wet, collapse. That stuff gets so heavy that it is very, very hard for those roofs to stay standing whenever they are covered in that wet ash. So most houses, even if the ash got cleaned off of them eventually, would have to deal with like structural damage because that is just really, 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 really heavy. Let's see. So I've got some famous volcanic eruptions for you. I think there's two of them. These aren't necessarily things that you have to write down. I just thought it'd be fun to get some real world experiences in here. The first one was in 2010. It was a volcano in Iceland named Eyjafjallajökull, which is super hard to say. So an ice cap covered a caldera volcano. So our caldera volcanoes are the ones that had exploded in the past and had that big tub underneath it. But it's Iceland, so an ice cap formed over top of it. So volcano, ice sheet, exposed earth. So eventually, that's really small font. In 2010, the volcano erupted and spit so much ash in the air it disrupted the most flights to Europe since World War II. So all of the flights that normally fly over Iceland, which is a lot apparently, had to be rerouted completely because planes could not see through the giant amounts of ash that came out of this volcano. The local populations also had to deal with a lot of flooding, which isn't necessarily something you'd think about with volcanic eruptions, but because the volcano was covering an ice cap, all of that ice that was exposed to that hot ash, gas, and lava that came out of that volcano melted, as ice does when it is exposed to hot rock. Um, so the city had to deal with a lot of floods that had to do with that ice cap melting. But they have since recovered. Everything's good. They think another volcano a couple miles away is due to blow in the next couple of years, but not as bad as this one did in 2010. So the next one and the last one is Mount Vesuvius. Mount Vesuvius is in Italy, and it is the volcano that erupted and destroyed the city of Pompeii in 79 AD. So Mount Vesuvius is a stratovolcano that erupted in 79 AD and buried the city of Pompeii as well as other villages. So this is Mount Vesuvius today. Still there, kind of depleted a little bit. It is still active. It has erupted in the past, like our lifetimes, but nothing dramatic, just like small spits of lava and magma. Nothing that would destroy cities. So Pompeii was buried in 13 to 20 feet of ash and pumice. That is a lot of ash and rock. And it preserved the entire town. That ash kind of mummified everything. So this is an example of a horse that was in the city whenever the volcano erupted. And it pretty much perfectly preserved it in this layer of rock. Now, if they were to like destroy this rock, which they don't really want to do because it is perfectly preserved, often they find skeletons underneath them. So there are a lot of people that have been preserved in this exact same way. I just didn't want to put a bunch of dead people on the board. But yeah, archaeologists discovered this entire buried city, and they've just been slowly excavating it all. But 30 to 20 feet of ash and rock is a lot of dramatic depictions. There are a lot of movies about Pompeii. There's a Doctor Who episode about Pompeii. Have to handle the pumice thing literally by it raining rocks, which is what it did. So pumice is volcanic rock, and these giant chunks of rock, as they are spewed out of the volcano and launched away, will fall to the earth. So, any questions about this stuff? All right, so perfect. If you have not done the Ed puzzle about this stuff from last week, do that now. It is, I think, just volcanoes on Canvas. It'll get you where you need to go. You should have time to do it. Even if you watch it on mute, I believe now you have the ability to answer the questions without having to watch the actual video, but you do need to answer those questions. The video is cool too. National Geographic rocks. So, yeah. Tomorrow we start new stuff. We will do thunderstorms, which will be another like PowerPoint exit ticket scenario. So, if you have any questions, please let me know. I'm more than happy to help out on catching you up on any of the stuff that I was not here for.